Okay, it is now time for us to begin yet another digital asset. Things are becoming more interesting, wouldn't you say, Steve?
I would say.
I mean, we've progressed from the floor. That was kind of simple. All right, that was very simple. Into the stage, a bit more involved, with a very interesting custom parameter at the end, allowing us to specify a floor. From there, we've moved into the character. With that, we got to see a custom shader, as well as a very simple but very elegant rig. Now, the pool. We're going to use some simple shapes. We're going to use some simple expressions, and one thing leads to another. Boom, there's a pool. In the next video, we'll be creating yet another custom shader, just to keep with the spirit of we must continue learning new stuff. And as we progress, as I have already said, we're going to be working into more interesting things. After the pool, we've got the ladder, and we've got the bleachers and the crowd, and all sorts of things yet to come. So we're finally starting to get to the good stuff. Now let's go ahead and jump over here to the whiteboard. I am not going to lay out all of the network, because here's the deal. We're about to get into more complex objects that would require a lot of time drawing out the network, and you're going to see the network created anyways. So I'm going to start scaling back a little bit in the theory explanations, because you've at this point seen several expressions. You've seen the creation of custom shaders on the whiteboard. So we're going to start using some of the knowledge that you should have already picked up and just going forward with Houdini and creating whatever it is we are creating with a little bit less theory when that's already stuff that you should know. So what are we going to do here? Well, first of all, what's our swimming pool going to look like? We're going to have inside of a swimming pool. We're going to have the outside. And then it's going to come down like such. It's as simple as that. So we have an inner and an outer part of the pool. The inner part of the pool is going to go down, and we'll be able to specify just how far it goes down. We'll be able to control the radius of the inner, radius of the outer. We'll be able to control the height of the whole thing. So we'll have quite a bit of control, but in the end, it's really pretty simple. We're also going to have the surface that runs around here, a controllable surface that's beveled. So if I was to take a cross-section look at it, basically it's going to look something like that. That's going to run all the way around the pool. Okay. Now we're going to have the ability to control the height of this, and we're also going to have the ability to control if it's going to be more squared off or if it's going to, be very beveled, if you will, very curved. So we're going to give ourselves those types of controls as well. So now that we know what the object is going to look like, let's think for just a second, how would we go about coming up with this? I mean, watching training videos are always a lot of fun. The idea is to pick up something from the training video so that you can then go off and create your own things. Well, here with these training videos, the goal that we have is to get you guys on your feet thinking. How would you go about creating whatever it is you want to create? So let's analyze this. Well, looking at it, looks like I've got a tube. How would I go about this area right here? Maybe some type of curve I could sweep around and skin it up. That looks pretty good. Now, of course, some of these things may be new to you. That's okay. By the end of this video, I think you're going to have a good idea of how you can go about working a little bit closer with rails and sweeping to come up with new surfaces. And we're going to talk a little bit about tangency as well, so we don't end up with seams in our swimming pool. So, just stepping back and looking at this, I see a couple of tubes. I see a couple of circles. And I see maybe a curve. And that's pretty much it. From all that, we should be able to construct what we're looking at here. Of course, we'll throw in some merges and some transforms just for good form, but that should do the trick. So, starting out, let's go ahead and put a side view in place. And let's go ahead and construct our first tube. So here we are looking at a tube, and of course the tube is going to come in halfway through the construction grid. Now, I want the tube to sit up on top of the construction plane. So obviously I'm going to move the tube and translate Y up. I'm going to take its height and divide it by 2. So we only need to move it just half that height up. And by doing that, we'll end up with the following. So once again, construction plane, and we will be sitting on top. So again, we moved in translate Y. Height, so the height of the tube divided by 2. Once again, just giving us that area right there. So now it's sitting on the top, but we're going to have 2 tubes. We're going to have an outer tube and an inner tube. So let's say that this is our outer tube. So I'm just going to call it O tube for now. So now we need an inner tube. And the inner tube is going to come in inside as well. I'm going to draw it just a little bit smaller so we can visualize it easier. Again, it's coming in, being cut in half by the construction plane, and we need to move it up. But where do we want to move it up to? We don't want to have it sitting down here. That doesn't make sense because it's going to have this slant going into before you get to the bottom of the pool, and that just really doesn't make a lot of sense. So what we need to do, if I back up a couple, is move this guy in such a way that the top of this tube sits flush with the top of the outer tube. So, of course, this is our outer tube. And this guy here is our inner tube. So to move him up, well, what do we need to do? Well, if we were to move the entire height of the outer tube, what's that going to give us? Basically, it's going to have our inner tube moved all the way up like such. Okay, so now instead of the construction plane cutting it in half, the top of the outer tube is cutting it in half. Fantastic. Now we just need to move it back down some. And hopefully by now, as you've been watching these videos, you're starting to get more into the mindset of, oh yeah, just look at this. If we were to move it down that much, he would then be sitting flush. Its top would be flush with the top of the outer tube. Well, how much is that much right there? Once again, it's just half of the height of the inner tube. So if we were to move the tube up all of the distance of the outer tube, the height of the outer tube, and then back down 1/2 of the height of the inner tube, you would then be left with that situation right there. That's the scenario we are looking for. So that gets us an inner tube positioned properly and an outer tube that is sitting on top of our construction plane. So let me go ahead and erase this out. All right, so now what do we need to do? All right, now we need some curves. We need a couple of circles that we can use to construct a very simple curve network that can be skinned. So again, looking at this thing from somewhat of a perspective view, we have outer and we have an inner tube. I'm going to create two circles. I want one circle to lie flush on top of the outer tube, and I want another circle to lie flush on top of the inner tube. Okay? So basically what we would then have would be this and this. I also want to take that inner circle and pump it through a transform going in a different branch of the network, because we can have one circle act as 1,000 circles if we wanted. They would just all have to exist in their own branches, which could be merged together at the end. I want to take the inner circle, transform it down, and I want it to serve as the bottom of the pool, of the part that you could actually jump in and touch the bottom. Okay, so not to be confused with the fact that the height of the pool may actually have it going further down like such. So we'll just use a transform to move that down. Now, come on, let's think about how big do these circles need to be. We already have the information at hand. Basically, our outer circle needs to be the size, radius, of the outer tube's radius. The inner circle, the size, the radius of the inner tube's radius. How about the height? We already have the height. Our tube, this tube right here, its height represents a flush top for all of our objects right now, all of the geometry. So we'll just simply use the height of our outer tube to control how high we're going to translate both of our circles up in. Piece of cake. So now we have two circles positioned exactly where we want them, and a third circle that's positioned at the bottom of the inner tube that will serve as a surface for the bottom of the pool. Okay. Now, next, it is time for us to focus on creating a curve that we can use to sweep around this guy, basically by making a series of cross sections that we could end up skinning. So how are we going to do this? Well, we're going to construct a curve, and Steve is going to just put in raw numbers, if you will, to give us a very predictable curve in the end. Instead of going in there with the curve tool and click, 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 we know exactly what we're looking for, and here is what we're looking for. Let me draw this out for you. See if I can give you kind of a straight line. So in the X direction, back and forth. Now, and y direction, of course, going up and down. We all know that. But I'll throw it in there. So starting out over here, we need to start out with a point, a point, a point, a point, a point, and finally another point. So let's go ahead and number these points, because when working in Houdini, you'll find that points always have an associated point number. So let's say that this is going to be point number 0, point number 1, point number 2, point number 3, point number 4, and finally point number 5. Now, if we were to turn this into a NURBS curve, what we would end up having would be a curve that started here, but it doesn't travel all the way through. In fact, that's still kind of rough. Close enough. All right, so it's not going to travel all the way up to those edge corners. But the edge corners being edge points, these points out here. But the question is this: why do we have those points there? Those points are extremely important. It's because of tangency. By having, so let's say our pool, here's our actual pool outer surface, right? So it's the outer surface wall. By having this point, and one of the points here, the very next point in, all in a perfect line, you're going to end up with tangency being established between two surfaces. What does that mean? That means we will not see a seam right there where this top surface lies on the top ridge of the pool. And we obviously don't want a seam. It might not look too bad with the pool, but I think it's a good idea for everyone to kind of figure out how to get rid of seams. So let's go ahead and undo some of these things. Bear with me. All right. So now that we have this guy, what's important? Well, first of all, in the creation of him, in the x-axis, this is going to be a -1, and this is going to be a +1. I just want you to get an idea of the numbers that Steve's putting down, why we're using these numbers. Again, very predictable curve. And going up in the x-axis, 0, or y-axis, excuse me, and going up to a value of 1. You'll notice that all of these guys right here have a y value of 1, keeping them all in line with one another. And these two guys will be perfectly in line with one another, and these two guys will be perfectly in line with one another in regards to the x-axis. All right. Now, we are going to use a couple of transform nodes to give control to select points on this curve. Well, why do we want to give control? Because if we were to manipulate the top set of points, and there's two ways that we can manipulate all of these points right here. First of all, let's take a look at 1 through 4 as a group. If we were to move 1 through 4 higher, couldn't we establish something that looks like that? Or if we were to go shorter, maybe something that looks more like that. Okay, that's by controlling moving those 4 top points, point 1 all the way through 4 in translate y, on the y-axis. Now, what if we were to take 2 and 3 and scale them in the x-axis? What's that going to do? That is going to tighten up our turns in the curve, or it's going to make it a lot looser, if you will. Meaning we could end up with a result that looks very tight, like such, or something that looks very loose, like such. So a lot of control. And basically we're going to call these two different types of control our bevel height, and that's just simply moving those 4 top points up and down, and our bevel width, which is scaling point 2 and 3 in and out in the x-axis.
And it's really important to note that neither of those operations are going to affect points 1 and 4 in their x-axis, which means that we're still going to have tangency with our tube.
These guys will always be perfectly aligned on both sides. Good thing to point out, Steve. All right. So now we could, of course, use group nodes and group points 1 through 4 and give it a name. We can also turn around and use another group and say, I put group 2 or points 2 and 3 in another group and give it a name, and then feed those into a transform node, and inside the transform node refer to those named groups. But we don't have to do that. We can simply wire straight into a transform node, and in the group, instead of using a named group, we can specify points right there. And that's what we're going to do. We're going to wire into one transform, and in its grouped points, we're simply going to say, let's use numbers 1 through 4. So we know that this right here is obviously going to be a translation Y. This is going to be our bevel height. We can also take and feed all of our geometry into another transform and say, let's deal with groups 2 and 3, and this is going to be our scale on the x-axis, so scaling in and out. So again, our bevel height, our bevel width, just to save time on lots of writing. Okay, so once we have this in place, the next thing we need to do is basically create a series of cross sections that run all the way around the 2 circles that we've created up here at the top. It's very easy to do. We will simply use a rail node. With a rails node, what's going to happen is we can take the output of these 2 guys, feed it into rails, and then coming in on the other side, the curves that we want to sweep this around, our rails, are going to be these 2 circles over here, which, I'll just draw it like this, because I'm not actually drawing the network here. So the guy that's responsible for making those 2 circles, there we go, we're going to feed that in there. So basically, you've got 2 upper circles, we're going to run them into a merge, and then we're going to take the output of the merge, I'll put a big M right there, and run that over into rails. That is going to result in the following: outer circle, inner circle, and all the way around are going to be, that's poorly drawn, these cross sections, these curves basically, this guy being duplicated over and over and over all the way around. Now here's the cool thing. We can now sweep a surface along those curves. So we can come out of this and we can simply run into a skin sop. And we'll just use the first input. There are 2 inputs. And we can tell it, we're going to sweep this guy all the way around. There's a couple of parameters that we're going to set, like let's make sure the resultant circle is closed, etc. Let's make sure that we maintain our original shape so that we don't shrink in a little bit. And Steve will go over those as he sets the parameters. But the result is going to be a nice, smooth, beveled surface that runs all the way around the top of the pool and has tangency with the sides of the pool, the side of the pool all the way around, so that there is no seam up there. No seam. Okay? So, with that, basically, we're just going to take the output of this guy, and we're going to run him into a giant merge. And this is kind of our merge all, where we'll take, remember the bottom circle that we used a transform to create? We'll end up running him in, and we'll run our outer tube in, we'll run our inner tube in, and we're going to have our swimming pool complete. Now, since we're all very comfortable with the whole floor object parameter we're going to be creating at the very end when we turn this into an asset, we can go ahead and take the output of this and tie this into another transform, and his job, put our display flag down there, his job is going to be to control the translate Y of our pool so that when we have an asset and we specify anything as the floor, in our case we're going to end up specifying the stage as the floor, then we're going to see our pool sitting on top of the stage instead of our construction plane. Okay? Anything you want to add to this, Steve?
Not right now, no.
Okay, so I think that's actually more detail than I was originally planning on going into, but that should pretty much do it. Let's jump over into Houdini. Let's start building this thing.
Okay, so let's jump over into Houdini and we can get started creating the pool.
All right.
So I'm going to create a new geometry object at object level. So tab menu, geo, enter to create that guy. I'm going to rename him to pool. I'm going to jump inside. You'll see that our display settings are set to hide out all the other objects, which is great. So we're only going to focus on the pool. I'm going to delete out the file and I'm going to create our first tube. I'm going to rename this guy to outer tube.
And let's go ahead and bring the construction plane up, just so that everybody can see with the grid there. There we go.
There we go. So I am going to give this guy a couple of sort of rough settings. We are going to control things like the radius and the height with parameters on our asset, but since we don't have an asset right now, let's just give it some rough settings. So I'm going to say a height of something around 4, and let's say a radius, I don't know, something like 6. And we can see that's our first radius. Let's make our second radius reference that. So ch rad x. No, rad 1.
There we go.
So yeah, with the tube it's rad 1 and rad 2. With this, some other primitives it's rad X and
Y
rad
and Z.
and, yeah.
Generally when there's an X, Y, and Z.
But yeah, in this case it's rad 1 and rad 2. So
Okay.
channel rad 1. We do want to create a NURBS object, and we need to set our center in Y so that we sit on the construction plane.
And we saw that as simply take height and divide it by 2.
Exactly. So we can take our height, divide it by 2, and we're going to sit up there on the construction plane.
Fantastic.
So I'm going to create a second tube, so tab, tube, enter, enter. Rename this guy to inner tube. Let's template this outer tube and bring our visibility down to the inner tube. So again, I'm going to throw in some very rough parameters. We do again want this guy to be NURBS. Radius, something smaller than before, so 5.5 sounds good. Let's reference rad 1 in our second radius, and a height of something around 2.5 sounds good. So we need to get this guy to sit with his top level to the top of the other tube. I'm going to switch over to a side view to do this, so space and 3.
Now you can go ahead and
hide out the grid so we can
Yep.
see. Fantastic. So in the front view, we can clearly see the two levels of the tops of the both tubes. So let's grab our inner tube and set it center Y. We want to move up the entire height of our outer tube, so dot dot forward slash.
Yeah, and do just that one
outer
operation
tube.
first.
Sure. Height. And that'll move us up so we're centered up on the top of the outer tube. And then we want to take our height away, but we only want to take half of our height away, so divided by 2. And that will line us up. And if we change our height, we'll see that we always maintain with the top. If we change the height of the outer tube, we
Nice.
always stick with the top, which is exactly what we wanted. So something like that looks cool for now. So space 1 to go back over to a perspective view. So we've got these two tubes in place. So I'm going to wire them into a merge now, and I'm going to create that merge all
That's going to be, the merge all.
right this
at the
second,
very
since we've got two pieces of geometry, and they're going to need to be wired into merge all at the end anyway.
end. Sure.
So I'm going to rename this to merge all. And let's get rid of our templating. So now we've got the two tubes. We actually have enough here that we could start building our asset. So I'm going to select all of these nodes by left click dragging over them. Shift C to collapse them down into a subnet. I'm going to rename the subnet to pool. I'm going to right click on the subnet and come to create digital asset. From this menu, we've all seen it before. I'm going to name the asset pool with the label of pool with a capital P. Again, we don't need any inputs. And I'm going to browse to select a new OTL file. So I'm going to jump up into our OTLs folder, and I'm going to create pool.otl. Accept that out. And again, we're only installing to the current HIP file. So I'm going to accept. That's going to bring up the type properties for our pool. So on the parameters tab, I'm going to create a folder, which I'm going to name to geometry. And inside this folder, I'm going to promote up some of the parameters that we've already created, the height of both tubes and the radius 1 of both tubes. So I'm going to come over to from nodes. I'm going to open up our pool, and on our outer tube, I'm going to grab our height parameter. I do want to again make sure that link names and labels are off. And let's promote up our height. And I actually want this to be the height of our entire pool, so I'm happy with the name that we've got here. But I want to disallow the artist to make the height equal to 0, so I'm going to set the minimum value, and I'm going to lock it to 0.001, just so that we can't quite hit 0 in our range. I also want to grab the radius parameter, but I only want to grab radius 1, since radius 2 is referencing radius 1. And I'm going to rename this to outer radius, and also the actual parameter name to outer radius, since this is the outer radius of our pool. And we can see the outer radius currently is locked with a value of 0. I'm going to change that to 0.001. I'm going to boost the upper range to somewhere around 5. This is just an approximate value. So now let's do the same for our inner tube. So I've expanded inner tube and the tube folder inside. Let's grab its height. Now this time, instead of calling this guy height, I'm actually going to call him inner depth, because it's kind of like the depth of the inside of our pool. And again, I'll lock him with a minimum of 0.001. And let's move that up underneath our other height, just to keep the two height and the two radius parameters together. Opening up radius, grabbing radius 1, promote him over. And I'll name this guy to inner radius. And again, 0.001 to around 5. So if I accept that, come back over to Houdini, we have height parameter that's going to control the height. If I switch over to wireframe, the height of our pool, the inner depth of our pool, and 2 radius values. So something like that kind of looks like the pool that we had on the whiteboard.
Now I think something you've done here needs to be emphasized as being pretty important.
Okay.
And that is, right off the bat, you created the digital asset.
Yeah.
Instead of waiting until you were pretty much done with everything, which is what they've kind of seen as we've been working along. Generally, when working on larger assets, that's a fantastic idea. Just get right in there, and you need at least 2 nodes. But once you have 2 nodes in place, go ahead and create your digital asset. And of course, I'm referring to a digital asset down at the geometry level. And then the reason for this, though, is because then you can just start adding all of your custom parameters right away to the asset, as opposed to creating custom parameters down on some SOP, be it a null or whatever, that end up having to be promoted up to the digital asset later. So anyways, that null or whatever it might be is acting kind of like a middleman whose job is, well, a temporary job.
And worse than that, imagine that you decide, okay, I've got this radius parameter on this tube and a height parameter on this tube, and you don't create a parameter on a null to control him. You just try and remember in your head that here's a parameter I want on my asset. And you're going on and you're going on, and you've got this asset, and maybe you have 20, 30, 40 parameters. You're not going to remember all the parameters that you wanted to originally be on your asset. But if you do them as you're creating them, and as they make sense to promote them up to the asset, you're going to find life a lot easier.
For sure.
So, great. So we've got the start of our asset, and if we need to add more parameters, and we are going to add more parameters, we can do that as we create them.
Yeah, the nice thing is now, as Steve is working, he's just building up the asset.
Exactly.
Excellent.
Fantastic. So I'm going to jump back down inside our asset, and let's create those 2 circles that run around the top of our pool. So I'm going to push tab and type circle and enter to create the circle. Again, we're dealing with a NURB circle. Let me template our altitude. Fantastic. We need a ZX plane oriented circle. The radius needs to refer to the radius of our outer tube in this case. So I'm going to grab outer tube /rad1. And we can set our second radius to reference our first radius. Now the reason I've grabbed the radius from the outer tube as opposed to the radius up on our asset is because I know that I want the circle to match the outer tube. So even though we know that the outer tube currently is following that outer radius, for whatever reason at a later date we may change that. But if we refer to the outer tube's radius as opposed to the radius up on the asset, if we make any changes to the outer tube, our circle will still match, which is exactly what we need. So we've got that circle in place. And that circle is actually perfect for our bottom, so I think I'm going to change things up a little bit on the fly. I'm going to leave this circle in place for the bottom and then transform him up to create the top, as opposed to putting him at the top and transforming him.
So you're actually going to put a bottom on this guy? Because this is our outer tube. Do we really need a bottom on that one? Because he's going to be sitting on the stage. But it's your call. It doesn't hurt if we had one on there.
I guess we don't need
No,
a
because
bottom.
it's going to be sitting down on a stage or a floor or something.
And we're not going to see that geometry.
Exactly.
That would be wasting render time.
Yeah.
Okay, scrap that idea.
So let's move him up.
Yeah, let's move him up. Cool.
I was just letting you know that I got your back. I'll back you on it if you
I
want
was
to leave
thinking,
it there.
you can put a bottom on it, but it's going to be sitting on a stage, so I don't know what came over me. Right, so let's set our center Y to be the height of the outer tube.
Now you may be concerned right now, those of you watching the video, that this thing is completely shaded as a surface. And over on the whiteboards, we talked about using this for its curve characteristics.
Exactly.
Don't worry, once we start pumping this into things like a rail SOP and all, we're in good shape. It'll treat it as a curve.
Treat it as curves as opposed to the surface.
That's right.
Cool, so we're aligned with the top of the pool, as we originally intended. And I'm going to rename this to outer circle. And instead of creating a new circle from scratch, I'm going to copy this guy, Control-C, Control-V to paste him, rename him to inner circle.
I mean, some of the expressions are going to remain the same.
Pretty much everything except for the
Outer
radius
goes to inner. Yep.
is going to become inner.
Nice.
which if we template our inner tube, we'll see we line up perfectly. So before we create the curve to run around our rails, I will duplicate this down to create the bottom surface.
Now we do need a bottom.
Now we do need a bottom here, so I'm going to wire this into a transform, which I will rename to move to pull bottom underscore xform. And we need to move down from our current location by the height of the inner tube. So translate y minus reference a channel. We're going to grab our inner tube's height parameter.
Excellent.
Fantastic. And we can take this right now and wire that into our merge. Let's just move the merge down, give us some room to work. So we can now take these two circles and create a profile curve, and with the three curves together we can create our top surface. So let's create our profile curve now. So I'm going to create a curve sop, enter to accept that and place it in. I'm going to call this bevel profile curve. We're dealing with a NURBS curve because we want the nice rounding on our curve. And the CVs, if we jump back over to the whiteboard, we saw we've got -1 and 0 in x and y. Z's always going to be 0. So -1 and 0, -1 and 1, -0.5 and 1. Thank you. 0.5 and 1, 1 and 1, and then 0 and 1.
Yeah.
So that's nice and easy to do. So we're going to start bottom left. So -1 in x, 0 in y, 0 in z. And these you enter the CVs in triplets of numbers, x, y, and z with commas. For the next CV, just put a space, and then x, y, and z with commas in between. So the next set, x is -1, with then 1 in y and 0 in z. -1, -0.5. No. -0.5, 1 and 0, -0.5
Yeah,
in
we're
x,
moving back over next.
1 in y, 0, 0.5 in x, 1 in y, and 0. So now we're over on the positive x side. Now we've got our top right corner, which is 1 in x, 1 in y, and 0, and that bottom right hand corner, which is 1 in x, 0 in y, and 0. If we push enter and bring our visibility down, we can see that curve. If we bring in our points, we can see the 6 points as outlined
and
on
let me
the
do
whiteboard.
this real quick, just in case anyone that's new to working with curves and points and all that are any confused.
Okay.
Basically, Steve needed to come up with an x, y, z coordinate for every point that we had, and when I had drawn this out, basically x is running back and forth down here. So this is where you can see that for this first point right there, what would be its numbers? Well, in x, we had a -1, comma. Where was he in y? He's in 0. And then where was he in z? Well, z's going to stay 0. Okay. Now, as Steve said, just a simple space in there as we start our next point. I'm not going to go through all these, but I'm going to go through a couple real quick. So for this point right here, well, what are we looking at? Well, x, first, we're still -1, so let me go ahead and put a -1 for x. Again, just a space between the set of numbers, a comma now. Y, well, where are we at? We've moved up for this guy. So we've moved up to a value of 1. So 1, comma, z, of course, is going to be 0. Moving over here, we've moved in the x-axis back, yay, so far. And it's 0.5 is the number that Steve's going to go with. So x is going to be negative because we're still on the negative side of x. So -0.5, comma. We're still at 1 up here. So 1. And, of course, z's going to be 0. Now, the next number, so if I was to, well, you stay, 0. I should have erased this guy sooner, but that's all right. So moving over to this guy, now x goes positive. So this is where now we have a positive 0.5. We're still up in y. That's why it's a 1, and z is still a 0. So, and then you can see how the other two are going to shape up. But that's how Steve came up with those numbers. To somebody that's completely new to working with x, y, and z coordinates, and you're just all of a sudden pulling all these numbers out of your head. It looks amazing, but this is in your head. You're just walking through where each point is.
Yeah, they're simply coming from the design of the points that we already laid out on the whiteboard.
Exactly.
Fantastic.
Otherwise, it just looks like black magic, because after you got finished entering this long, cryptic line of numbers, you just hit enter, and There's this curve that looks exactly as it was described on the whiteboard.
Isn't everything in Houdini black magic?
No, not really.
I am going to be really picky, because instead of profile curve, I want to call this bevel cross-section,
I like that.
because that makes more sense.
I like that.
And it was going to annoy me if I had that as profile curve for the rest of this video. So, bevel cross-section.
Though I have no problem with it being a profile curve.
It is a profile curve.
Because it is a profile.
It's also a cross-section.
It's very much a cross-section. You're about to make a bunch of cross-sections.
Yes.
Okay,
Cool.
So let's do it.
So let's deal with our bevel height and our bevel width,
Okay.
which we saw on the whiteboard is going to be two transform stops where we specified the groups directly as ranges of points.
Let's go and turn our point numbers on.
So-
Look at you reading my head.
So
Excellent.
yeah, we can see our point numbers here. We can see 0, our first point we created, 1, 2, 3, 4, and 5. So 1 through 4 are going to control our height, 2 and 3 are going to control our width, exactly as we saw over on the whiteboard.
Mm-hmm.
Fantastic. So let's right-click on the output of the bevel cross-section, and I'm going to create a new transform stop. Click to select that, enter to place it in our network, and I'm going to rename this to bevel height underscore xform. And in our group, instead of creating a group and specifying a group by a name, we can simply specify a range of points. If we use 1 minus 4, that specifies 1 through 4, which if we start translating these guys, we do have to say that the group is points. There we go. So group type equal to points, because saying 1 through 4, it's not going to be able to guess what the group type is, because it could be primitive numbers. So there we go. So that's translating those top 4 points.
Nice.
So what we can do is we can promote this up to our asset as our bevel height parameter, but before we do that, let's create our bevel width transform as well. So I'm going to right click on the output, come back down to transform in our history, single left click, enter to place that into our network. I'm going to rename this to bevel width underscore xform. Now with our bevel width, we're only concerned with points 2 and 3, so group is going to be 2 minus 3. The group type is going to be points, and we're going to be dealing with scale X in this case, and we can see as we scale these, we tighten up our bevel, or loosen our bevel.
Mm-hmm.
So we've got the two parameters, so I'm going to right click on our pool asset up in the path gadget, come down to type properties, that is off the bottom of the capture region, and I'm going to promote up those two parameters. So on bevel height, I want to promote up translate Y, so I'm going to right click on translate Y for bevel height, and come down to export parameter to type properties. And since our type properties is open, that's going to be exported to our pool asset. And I'm going to come down to bevel width. Let's set our scale X back to 1 for now. Right click on this guy and export parameter to type properties. Now, let me just resize this so we can see what's going on. Translate Y needs to become our bevel height. And scale X needs to become our bevel width. And I'm also going to shift select both of these guys and drop them into our folder for our geometry related parameters. So we can accept that. We can see that these are now being controlled by a reference, and if we right click on our pool and come down to parameters to get a pop-up of our parameters for our asset.
Maybe we can set some ranges in a second too.
Yeah, we could do. So we have our height. It would be nice to be able to also move down.
Mm-hmm.
And then we have our bevel width. Cool. Now, this is just on the fly, but if you see we put a height of -1, we actually get to 0. So what I might do is go to the expression on translate Y and subtract 1 from our bevel height parameter. So when our bevel height parameter is 0, it equates to -1 and actually puts us down on the flat.
Okay.
So what I'm going to do, I'm going to go over to our bevel height transform, take our reference to this bevel height parameter, and simply subtract 1 from that, which means when we have a bevel height of 0, we are completely flat, and now as we start to move up, we then control the height. It makes more sense than having a negative value give us a flat surface.
Absolutely.
The bevel width I am happy with as it stands. So what kind of ranges were you thinking for these parameters?
Well, right now, bevel height is so, that's what I'm looking for, sensitive. So, maybe set it to a range of
2?
0 to 2, yeah.
That sounds cool. So, I do want that to be left at 1. So let's right click on our pool, come down to type properties, grab our bevel height, a range of 0 to 2. I'm going to leave it unlocked because if we put a negative value in, we're going to get a weird looking bevel, but it may be something that you'd want. So if we accept that, we can see if we were to put in a negative value, we get a sort of inverted bevel, which the artist may wish to go with that. So we can, and again, we can go higher if we want.
If need be, that's right.
But
yeah,
that gives us a nice range. And
bevel width, maybe lock it from going all the way to 0.
okay.
Because I can't tell. Are they crossing over?
They just about touch, so they're at the same position. So I'm going to right-click on our pool asset, come down to Type Properties, bevel width. Let's lock that at 0.001.
Yeah, sounds good.
And that was a bit extreme at 10.
It was.
7?
Sure.
Accept. Even 7's kind of extreme, but you might want that. So.
Maybe. Artistic pool. All right, very nice, very nice.
Cool. So now that we've got our bevel in place, we need to merge our two circles together, and then we've got both the cross-section and the rails, and we can use the rail SOP to generate the cross-sections for our bevel surface. So I'm going to middle-click on the output of the inner circle, and that's going to branch off of our inner circle. And I'm going to create a merge, and enter, and enter. And then I'm going to wire the outer circle, single left-click on its output, single left-click on the input of the merge. So wire the outer circle into the merge. I'll rename this to merge rails, or even rail circles. And I'm going to grab our cross-sections and move them over to the left. That'll become apparent in a second. So let's push tab, and let's create a rail SOP. Enter, and enter. And if we middle-click on the inputs to the rails, we have our cross-sections, which is why I wanted to name that curve originally cross-section. And we have our rails, which are the circles. So let's wire our circles into the rails. Let's wire our curve into the cross-sections. And if we bring up our visibility, we're now seeing the curve swept around our circles. It has been flipped over. We can check, use direction, set the direction to an inverse, and that's going to flip that back up. So I checked use direction. Direction in Y with 1 was giving us upside down, so you simply invert that, and that's going to fix that problem nicely.
Let's go ahead and kill out the point numbers real quick. Yeah, there we go.
So now we can take this surface and we can wire it through a skin. And we can bring our visibility down to the skin. By default, we're not getting a closed surface. So let's change VWrap to on, and that will close our surface. And let's push space 2 and come to a top view. And I'm going to template both of our tubes. I'm going to shift click on the template of our tube. Notice our bevel surface, it's not aligning with our tube surfaces, and that's a problem because this is supposed to flow from the tube into our bevel, over and back into the other tube. It's easy to fix. We simply need to check preserve shape. Keep an eye on the viewport when we do. That's going to move it back out to line up with our tube. So space 1 back to perspective. So let's take our skin, wire that into our merge all, and let me just bring merge all down here. Bring our visibility over to merge all, and let's get rid of any templates. So I templated our merge all, and then untemplated it. It's going to remove any templates.
Very nice.
Cool. So let's just play around with some of our parameters. So I'm going to right click on pool. I'm going to bring up the parameters for the pool. So we can change our inner radius if we want. We can change our overall height if we wanted to, our inner depth if we wanted to. We can change the bevel height and the width
Very nice.
of the bevel. So we've just got one extra parameter to add, and that's going to be for our floor object.
Okay.
So I'm going to close out these parameters. I'm going to right click on our pool asset and come down to type properties. That's off the bottom of the capture region. And we've seen already that we can create an operator path. We've got kind of a long list of parameters here, and the floor object I want to be separated slightly from those parameters, but it doesn't really deserve its own folder. So what I'm going to do, I'm going to create a separator which simply acts as a divider between these parameters and parameters below that. I'm going to create an operator path underneath. I'm going to name this guy in the exact same way that I named our floor object operator path in the stage, and that's so that I can simply copy the expression from the stage, and it will still work here because we're using relative referencing, and we're going to have the same named parameters, so everything will just work off the bat, which is fantastic. So that was floor, capital O, B, J. The label, floor object. I want to make sure that it's using object geometry only, and we can accept that. And if I bring up the parameters for our pool, we can see we get that divider, and then we've got our floor object. Let's bring up the browser. We want our pool to sit on the stage, and accept. I'm going to jump up a level to see our pool asset, jump up another level to the scene level. I'm going to double click to jump inside of our stage, double click on our stage asset. I'm going to select the sit on floor obj underscore xform, control C to copy that, including its expression. I'm going to jump up to the stage, up again to scene level, jump inside our pool by double clicking on it, jump inside the pool asset by double clicking on it. I'm going to single click to make sure I have nothing selected, control V to paste in this transform, which is coming along with the expression as well. And let's just wire our merge into that transform. We can already see that our pool has jumped up, and if we were to turn on show all objects, we can see that we've jumped up to sit on the stage, which is fantastic. So I'm going to turn off show all objects, set it to hide other objects, and with that, let's jump up and save our operator type. I'm not going to match the current definition because we're going to need to jump back in and set up our shaders in the next video.
All right, well, that's everything we set out to do, and that will conclude this video. Thanks a lot.